Okay, now let me get into actually showing you D3 Windows Hot Backup and how it's set up. So in order to set this up and manage it, what I'm going to use is the D3 Administration Console. The Administration Console allows you to manage any D3 system that you can get to, whether it be AIX, Linux, or Windows. As long as you can see it on a network, and make a TCP/IP connection to it, you can manage it from the admin console. And what I'm going to do here is, since I'm using I am hooked up to the internet, but I'm being assigned IP addresses through some strange DHCP server I don't recognize, I'm going to be using IP addresses instead of host names. So this 172.30.2.44 is the secondary server, so I actually want to start off from the primary machine. 2.30.4.99. Okay, if you haven't seen the admin console, this is how it currently looks. It's we're going to actually just focus on one of the components that has recently been added, the ability to configure hot backup. Okay, in the hot backup management section of the admin console, we have the ability to manage both the primary server and the secondary server. We can set the logging options. Once the secondary server has been set up, we can start and stop it from here. And then, as I mentioned, we can take a look at the queue and we can inject the transaction timer into the transaction flow to see how long it takes for the data to get from one side to the other. Setting up the primary server, the server name by default is PSC, which is Primary Server Control, or stands for something, I don't know. The queue path is, as you can see, it's the fully pathed FSI file. So it's the FSI DM account. The FHB is the file name, and P for primary is, I do know what that stands for. P for primary is the data level. Modulo of 1001. Looks like as I was running through this prior to setting this up, I chose 1001. And the max entries is 0. That means that it's unlimited. There may be a case why you'd want to set a max entries value to keep the queue from running out of control, perhaps, and filling up all your disk. But we haven't seen a need for that. But it's there. Okay. So if I take a look at the secondary server, actually, let me go back and save my configuration here. Okay, so the primary server has been created and updated. My logging options on the primary server is I'm only logging DL type files, which is what we recommend, as I mentioned. You can switch over to log all files if you'd like. And a global update logging, we want to turn that on. So these are the logging options. This eliminates the need to go to TCL and enter those FHB log all commands. Okay. That's all you do on the primary server. It is set up. The next time you add a transaction to a file that has a DL type D pointer, it is now going to write that transaction to the primary queue. And that's everything that's involved. The second part of this would be to go over to the secondary server. So I can log out of this guy. This will tell me that I'm disconnecting from the primary. And it brings up the login screen. I'll put the IP address in here of the secondary machine. Okay. The admin console, by the way, if you're managing a lot of D3 systems and they're available to you, like if you're a VAR reseller and you're doing support for your system, If you have the admin console, you can just connect to them over the internet by IP address or by host name or URL and manage them remotely. And as we add more and more to this admin console, that'll become more and more useful to you. On the secondary machine, we'll go to the secondary server. And it's got the secondary, its server name is SSC. And the secondary queue is also an FSI file, and it's also in the FSI DM account, but the data level is S for secondary. Modulo by default is 101. The default number of subqueues is 3. Again, that can be tuned based on needs. The idle time sleep is 15 seconds. That means if it goes out to the primary machine for transactions and doesn't find any, it'll come back and sleep for 15 seconds before it goes and tries again. The primary host name, I'm going to use the IP address. And the auto start option, that's saying, do I want hot backup to start up automatically every time D3 is started? I'm just going to leave that at no for now. Say that, and that's all that's involved to configure the secondary machine. The secondary server's been created and updated. And now on the secondary machine, since it's actively going out and doing the work, I actually need to start that server. Again, the primary machine is just the queue. It just sits there. There's no actual processing being done on the primary machine other than writing to that queue. On the secondary machine where it does all the work, we actually need to start the server. And it's prompting me again to save, but here I have the big blue button, not to be confused with the big red button. Sean missed that. I'll start hot backup. Okay, the server's been started. So hot backup's been configured on the primary machine. It's been configured on the secondary machine, and it's been started. And now, as I start adding transactions to the primary machine, they'll be replicated over to the secondary machine. One of the features of the admin console utility here for hot backup is the ability to show the queue. I can take a look at the health of the primary queue as far as number of transactions, and the secondary queue. Right now, for graphical display purposes, it tells me there's about 60 transactions in both sides, but we know that we're not actually doing anything there. But I'll actually start the queue monitoring by hitting the start button here. Okay, now I can see that both queues are empty. So again, I've got a primary machine running here in the foreground, the secondary machine running in a virtual machine in VMware. And if I go ahead and go over to, say, the SQL demo account, I have a little basic program here, and I've got a test file here called FHB demo. And as you can see, this D pointer is DL. The way to create a file, a DL file, would be either to use the create file command with the L option. That means that anything added to that file will be logged. Or the set-D pointer command. You can take your existing files and change them from D pointers to DL pointers. Okay. So what I have is I've got a file here called FHB demo. Right now it's empty. And I've got a basic program that will populate that file. So it's going to loop through and write records to that file and display a little counter. And as you can see immediately, the queue monitoring senses that it's got transactions in the queue. So I'm up to 35,000 records. This says I've got about 35,000 records. And as the secondary queue comes over and brings them from the primary to the secondary machine, you can see the primary queue drains, the secondary queue has transactions in it, and eventually the primary queue should be down to no transactions, and the secondary queue should be down to no transactions. So, and this is just a quick demo. Obviously, I wrote a bunch of records to a file in a loop. It's not really normal processing. But during the course of the day, if you were to come in and use the admin console here to look at the queue, you can see the number of transactions in the primary queue, number of transactions in the secondary queue, and the idea, again, is to keep these queues down as close to zero as possible. So if you want to add more and more helper queues on the secondary machine to write these transactions out faster, if you want to tune the modulo of the queues so that everything's in a primary frame, there's a lot of tuning things you can do to make sure that these queues, remember, stay as small as possible. With a hot backup configuration, you also want to be able to make sure that you minimize the data that's in transit. So you have the ability to inject what we call a transaction timer into the transaction flow. This will give you an idea of how long it takes a transaction to make it from the primary machine to the database on the secondary machine. So as you're adding transactions to the primary machine, you inject this timer, like a tagged transaction in, and it will follow itself through all the way through, and once it makes it to the database, you can find out how long it takes. And we can actually test that too. Okay, so I injected 3 transactions into the data stream. What you'll actually get is it injects 3 timed transactions into the data stream so that you can see how long it takes for them to get to the database. The theory behind that is, as you're writing transactions to the primary queue, you've written them to the primary database, okay, the backup of them is still sitting in the queue, so they are at risk. Until they make it over to the secondary machine and get applied to the secondary database, that's what we call your data at risk, because if this machine goes down, those transactions haven't made it to the secondary queue. So in order to find out how much data you actually have at risk, it's kind of hard to stop everything and say, okay, how big is the queue? Even though you can look at the health of the queue by looking at the size for tuning, it's hard to see how much data is actually at risk. By inserting a transaction timer into the data stream, you can get a timing of how long it takes your transactions to make it to the other side. So if you inject the transaction timer stream in and you see that it takes 25 seconds to make it to the other side, your data at risk is 25 seconds worth of data. In real life, it may be 2 or 3 minutes worth of data that you have at risk, but you've actually shrunk down this window of data risk as far as you possibly can at a very low cost.